Today we will discuss about the equation of a plane progressive simple harmonic wave. Suppose we are having a wave that is traveling in the positive x direction with velocity v. Let the particle cross its position at O in the positive direction. So at O, its displacement at any another time can be shown as it is starting from the mean position. So the function is sine. So y at 0 comma t is equal to r sine of omega t, where r is the amplitude and it is the sine function. Why the sine function? Because it is starting from the 0. If it had started from 1, then there will be a cosine function. Now we already know that omega is angular frequency and angular frequency is equal to 2 pi by t. So omega is equal to 2 pi divided by t. It is called as angular frequency. Now let us see, when the disturbance reaches this particle, so at p its displacement will be equal to x. But one thing should be understood: the disturbance reaches the point p at a later time. That means this particle lags behind the particle here by a phase angle of phi. So when we talk of the displacement of the particle p, that is y is x comma t is equal to r sine of omega t minus phi. This minus phi is the phase lag, because as the wave progresses, there is a phase lag between the particle vibrating later and the particle vibrating earlier. Because at this particle the disturbance reaches at a later time, so when this particle vibrates, there is a phase lag between this particle and this particle, because this particle is vibrating at an earlier time, this particle is vibrating at a later time. That is why x comma t is r sine of omega t minus phi, where x is the displacement of the particle at point p, and at point 0 the displacement of the particle x in the x direction is equal to 0. So y is 0 t r sine of omega t, and y at xt is equal to r sine of omega t minus phi. Now let us discuss about this phase angle. We know that one wavelength equals to lambda, and lambda corresponds to an angle of 2 pi. Which means when the wave completes one wavelength, it completes 2 pi degrees. So we are having a path length of x. How much angle is this x equal to? So that can be got, pi is equal to 2 pi divided by lambda into x. That means a phase angle of phi is equal to 2 pi by lambda into x, where x is its path length and 2 pi by lambda is the conversion factor, as the path length lambda, or when the wave travels one full wavelength, it subscribes an angle of 2 pi. So it should be borne in mind that the phase difference pi is equal to 2 pi by lambda into x, where x is the path difference, phi is the phase difference. Putting the value of phi in here, we get y x comma t is equal to r sine of 2 pi by t into t minus 2 pi by lambda into x. Now getting 2 pi by lambda common, when we get 2 pi by lambda common, here we have not lambda, so lambda appears in the numerator. So lambda divided by t into t minus x. Now lambda is the distance or the wavelength, t is the time period. So distance divided by time is equal to velocity. So here velocity is equal to lambda divided by t, where lambda is the wavelength and t is the time period. So we can replace this lambda by t by v. So y x comma t is r sine of 2 pi by lambda into vt minus x. This is the equation of a plane progressive simple harmonic wave that is traveling in positive x direction. Talking of the wave, plane progressive wave traveling in negative x direction, the minus sign needs to be replaced by the plus. So the equation becomes y x comma t is equal to r sine of 2 pi by lambda into vt plus x. It is the equation of plane progressive wave in negative x direction, and in positive x direction this plus is replaced by the minus. So the general form of a plane progressive simple harmonic wave traveling in x direction is equal to r sine of 2 pi by lambda vt plus minus x. Now, if phi 0 is the initial phase difference, phi 0 is epoch or initial phase difference, in that case the equation of plane progressive wave yx comma t is equal to r sine of 2 pi by lambda into vt plus minus x plus phi 0. This wave starts from the mean position. If it starts from the extreme position, in that case yx comma t is equal to r cos of 2 pi by lambda into vt plus minus x plus phi 0. In this case it starts from the extreme position, and in this case it starts from the mean position, or in the sine case the wave starts from 0, and in this case the wave starts from maximum amplitude. Another way of representing the equation is, this is the general equation for the plane progressive wave that is simple harmonic in the x direction, whether it be positive or negative. Here we will multiply 2 pi by lambda with both vt and x. We get y x comma t is equal to r sine of 2 pi by lambda into vt plus minus 2 pi by lambda into x. This becomes r sine of 2 pi by t into t plus minus 2 pi by lambda into x. Now we know that 2 pi by t is the angular frequency omega. 2 pi by t is equal to omega, and this 2 pi by lambda is a constant called as k. This k is called as propagation constant or angular wave number. So replacing this by omega and this by k, we get the equation as r sine omega t plus minus k x. So the equation of a plane progressive wave, its general equation can be of this form also. So r sine omega t plus minus kx, where omega is the angular frequency and k is the propagation constant or angular wave number. Thank you.